Hi guys, if you are listening to this video, it means that you are interested in how to run binary logistic in SPSS. We have made a series of videos on binary logistic, but just in theory. We show you how to estimate coefficient and how to interpret them, and as well as the method that is being used in order to estimate coefficient of logistic regression and so many other notions. But now we are going to show you how to implement a binary logistic in SPSS. So binary logistic, as you know, is a method used to explain binary phenomenon. The phenomenon can be a disease. So we search to explain what causes, for example, a disease. Is it due to each or other parameter? So binary logistic, we can also search for for example, of a disease. So we can use logistic regression in order to analyze what factor is influence significantly the disease, the appearance of disease, which factor is a risk factor or a protective factor. So in binary logistic, we will show you how to run it as well as the interpretation of estimation results. So if you are going to run a binary logistic, so you will use a tab analyze. So when you are in analyze, you go on regression, and you choose binary logistic. Binary logistic. In this case, we are going to use binary logistic in this example to explain client reputation in bank sector. So in bank sector, you can define a variable called reputation in order to explain whether or not a client is good or not for a bank. So in you are in a person that have bad reputation based on your future loans, based on your based on your habit vis-a-vis your bank. So the bank can class you in good or bad reputation side. So we are going to use uh, this variable called reputation in order we are going to use other variable on our database. We can be sex, gender, can be gender and age, for example, in order to help you explain whether or not a client can be good or bad reputation. And this is a model that can help you uh, to know whether or not to give a loan to a client or not if you are a banking sector. So when you go on the analyze regression and binary logistic, you show this window. So here we need to put a dependent variable. Our dependent variable is a reputation. So here is our variable reputation that we select on our variable list and use this arrow in order to click this arrow, and the variable will go on dependent variable. So to explain the reputation of a client, we choose in the first case the age which is a quantitative variable. So as age is quantitative variable will not change here in categorical. This tab categorical. If sex this age was categorical, we should have used this arrow in order to put age in this area. So as age is quantitative variable, we'll just let it like this. So our dependent variable is reputation, and our covariant is age. So there are so many options. We just click on OK. So we'll come back a little bit sooner on it. So we'll just go back in the final result, the last table that is that we are seeing on our screen. So we have our dependent variable, the age, and the intercept, the constant. So here is the significance of our variables. So the age at 10% level is not significant. So here is the exponential of b. That what we call in our theory, theoretical tutorial, the adjusted odd ratio. So having if age was significant, we could have said that age is a protective factor. So which means that when age increase, the probability of being in bad reputation decrease. So age is a good factor. So bank will also need to make most confidence in participation in clients that are more age. That age is very most high. So we'll come back on our tab analyze regression, binary regression, binary logistic, and we show that we can save so many other options. We can go on option, so we can click on interval, confident interval of the odd ratio of the exponential of b at 95%. So we can change this threshold. So this threshold means that we are searching for 5% significance. So we can put 19% in order to say that we are searching significant at 10% level. So the probability threshold is 15%, and removal threshold is 10%. So we can we click on OK, and we will see that in our last table here we'll have the confidence interval for the exponential of b, as we didn't have in this last result table. So we click on continue and we click on OK, and we'll see that our variable age may be not significant at 10%. You can see that the odd ratio is there on our table. So if age was significant at 10%, we consider that age is significant at 10% level, we can affirm that age increase lead to decrease of chance to be a bad reputation client of a bank. So we will go on a little bit deeper in our analysis in order to show you what age category can most influence in the probability of being good or bad reputation. Because before that, we will show you the classification table. This is the classification table of our probability, which means that we have 6% in our sample that were in good reputation that are now in good reputation. So we also have 11% that were in good reputation that are classed in bad reputation. That means that our percentage of be in bad reputation, the classification percentage of correct is just 35%, which means that our model is not very good. So we'll come back on categorical age classification. So we have class our age. As you can see on in this in our database, we have class age between three categories. We have a category of clients that are aged between 28 and 35. We have 36 to 45, and we have more than 45 age old year old. So this variable take the value 1 if you are in the age 28-35. Is a variable that take a value 1 if you are in 28 to 35, and 2 if not. And the variable 36 to 45 take 1 if you are in 36 to 45, and 2 if not. So lastly, age more than 45% took the value 1 if you are more than 45 year old, and 2 if not. So we'll analyze, we go on analyze regression and binary regression. We remove our variable age and just put our variable age 28 35. So we'll go on categorical, which to select our variable and use the arrow to put it in categorical covariate, because age 28 35 is a qualitative variable. So we click on continue. In option, we also have confidence interval. So we continue. We can also save, for example, the probability of predicted value. So we'll just let it like this for now. So we click on OK, and we have a result of age 28 35. So which means that you see that the old rate adjusted old ratio is more than 1, even though age 28 35 didn't significantly influence because p-value is superior to 10%. If we take 10% level, you can see that B age between 28 to 35 is risk factor, because old ratio is more than 1, which means that old ratio of 2.16 mean that belonging to this age group multiply the probability of being in bad reputation by 2. So the bank should very look at persons which are aged between 28 to 35 before allowing them to have a loan. So we'll do the same thing in other groups, other age groups. We'll take age 36 to 45 year old group and click on OK, and we see that it's not also significant, but you see that in this category the old ratio have decreased. It's less than 1, which means that person in this age group can be have more probability to be in bad in good reputation sites. So we look at the last age group, which is more than 45 year old. So we put more than 45 year old in our regression covariant and choose categorical. So in this case, we will say, for example, we go in save and save probability of prediction of our model. So we click on OK. We see that in our final table, age more than 45% influence significantly to the appearance of a factor of reputation, influence significantly on reputation, and is a protective factor because old ratio is less than 1. So odd ratio of 0.3 mean that when belonging to group age of more than 45-year-old, decrease the risk of being a bad reputation client. So when you belong to a person which are in this group age are at 0.3 times less, have 0.3 times less chance to be in bad size population, which are those who are on bad reputation side. So being aged between 45% is a good thing for a bank because the client are more likely to be in good reputation side. So we can see the odd ratio, which is between 0.1 and 0.96, which is a good sign that at 10% level we can affirm that age more than 45-year-old is a good thing for a bank. We can see also in our classification table here that probability of being in the good be well classified by a model when you are when you are the probability of being well classified is 58% and 68% in good and bad side. So we have just remember that we have click on the icon save probability. Save probability. We go on our database and we look. We see that last column of our logistic regression that the probability of prediction of being in one has been computed by SPSS here. So you have the probability of being of the every client to be in good or bad to be in bad reputation, which is here. So you can use it to analyze your regression logistic using the fact that the threshold is 50%. That is the threshold that is used to classify people in good or bad reputation. So that's it for today.